Okay, hello, welcome to my channel. Okay, in this video we want to evaluate this nice looking integral. All right, so this is the day 17th, all right, of our 30 integrals in 30 days. So what I want you to do is this. I want you to give me some integral problems, all right, 5 integral problems from you. I'm going to be treating them from the day 21st to the day 25th. So this is 17, 18, 19, 20. From 21st, okay, you bring your problem. We're going to treat your problem 21st, 22nd, 23rd, 24th, and 25th. So 5 problems, all right? So you just put your problems or the integral questions, in particular integral question, because we're just dealing with integrals, right? You just put your integral questions in the comment section below. Okay, and that's very nice. But right now, let's just go ahead and check this out. First of all, I want to tell you something. I made this up, okay? So it may look so much, right? But it is very simple. Okay, so let's just go ahead and check some things out. So I made it in such a way that I will start by doing a use-up, right? So that's the technique we're going to be making use of here. We are going to be looking at the domain of the secant function. When you have a function like that, a trigonometric function, logarithmic function, or whatever, you always start by looking at their domain. Could the use-up be possible? So I'm going to say let u be the domain, which is just e to the power of negative 2 over x. All right, and then this begs to be differentiated. So that means we're going to have the derivative of u with respect to x to b. So when you differentiate the exponential function of a thing, first of all, know that the exponential function will remain, and then we'll have to go ahead and take the derivative of the power. So real quick, the derivative of this will just be 2 over x squared. Now this is it. If you have negative 2 over x, right? So what you want to do is to replace this, to rewrite this in its index form. That will be negative 2 times x to the power negative 1. And of course, it's now visible that if you put the negative 1 out front and subtract 1 from it, you're going to have 2x to the negative second power, which that is what we have right here. Okay, great. So we're done with differentiating. We can put the dx over here. Okay, nice. Now that means that this integral will become the integral of, so let's see this. All right, okay, so let's split the squares to all the terms, right? So the square will be to this, that will become e to the power of, well, negative 2 over x, right? And then we put the square down here, that will be over x squared. All right, then we square the secant function, so I can say times the square of secant of that is e to the power of negative 2 over x. So you notice that the square will not enter the domain, rather we are just squaring the function. Okay, very nice. So we put the dx over here. I don't have much room anymore, so let's continue here. Now this is going to become, so you notice that if we have 2 over x squared e to the power negative 2x dx, we can just replace it with du, right? Something here is closer. This is e to the power negative 2 over x squared. So the only thing lagging is 2. We have the dx, so we just have to put 2 here, and it's very simple. We can just multiply this by 2. That means the 2 is included, right? But we've just changed the function, so we need to correct it by dividing it by the 2 again. So we've just multiplied this whole integrand by 1, 2 over 2, right? Where we can push these 2 out front, and then use these 2 to replace everything, or to make the replacement possible. So I'm going to put the 1/2 outside. I'm going to take out the 2 in the denominator. Then this 2 times this, okay, over that. Then the dx, all of this will become the du. So that means we just have secant squared of e to the power of negative 2x is just u, right? So in place of that, I'm going to put in u. And then notice that 2 times e to the power of negative 2 over x squared dx is just du. So that means in place of that, we're just going to put in du. So we are done with the replacement. We've changed everything from the x variable to the u variable. That means we're going to have 1/2 of, well, to find the antiderivative of secant squared of u, you notice that the derivative of tangent of u is secant squared of u. So the antiderivative of secant squared of u will be tangent of u, right? So that means this is going to become tangent of u. Well, we need to get back to the original variable by doing a backward substitution. So what is u? Well, from here we saw that u is e to the power of negative 2 over x. And since we are done with the replacement, we can add an arbitrary constant, and this right here is the antiderivative of this function over here. Okay, thanks for watching. Please go ahead and drop your questions, as I said, in the comment section. I'm going to pick the best 5, right, and we're going to treat them from the day 21st to the day 25th. And please share these videos with your friends. Okay, thanks for watching.